So the first topic of these talks is fertility, which relates to the numbers of births that we might record in society. And within this first talk, I'm going to focus on a number of topics. First of all, the distinction between period and cohort measures of fertility, but here this also applies to other demographic measures. I'll then look at the crude birth rate, the general fertility rate, and finally the total fertility ratio. So here this is links to the POP group training later, in that the total fertility ratio is something that POP group estimates and that you can enter into POP group when you're producing your projections. So let me start off with one of my favourite graphs. So here we see a time series of the numbers of children per woman starting in 1958 and moving forwards to 2008, and we can see a sharp decline in the numbers of children per woman from the late 60s, coinciding with the introduction of the pill. And we can see from 1980 fairly low levels of fertility or numbers of children per woman, under 2 on average. And what's quite interesting is we see an increase in the number of children per woman from the early 2000s onwards. So this is something that wasn't really predicted by demographers, but it's something that happened across many different areas. So here, if we look at a graph for districts within Yorkshire, we can see here a time series from 2000 onwards and a similar measure here showing the number of children per woman. And we can see that increase in the numbers of children per woman over the 2000s occurs in all of these different areas. So something that wasn't predicted by demographers is something that was quite widespread, occurring in many different areas. So an interesting regularity and something that is actually quite hard to predict, and in some ways that encapsulates the challenge that we have when we try to produce projections of fertility, but also of population into the future. If we think about the question of how many births do women currently have on average in the UK, this is actually quite a difficult question to answer. And the reason it's difficult is that many demographic processes or events take place over a long period. So if we think about an individual's fertility, this takes place over a 30-year period from the age of 15 up to around the age of 45. So we can ask a woman who is 45, say in 2014, how many children they've had, but this is an average for a group who had their children at an earlier time between the period 1981 to 2014. And it might not reflect the fertility behaviour of women now. But if we ask younger women in 2014, by definition, they haven't completed their fertility years, so an average would likely be inaccurate. And this really is a key demographer's dilemma. We're interested in the most up-to-date measures of behaviours and outcomes, such as the numbers of children per woman, the years of life lived, that are actually the result of a process that takes place over a number of years. And really this gives rise to 2 approaches of measuring things like fertility, and these are period measures and cohort measures. So if we think about a period fertility analysis, this is looking at fertility as a snapshot, cross-sectionally at a particular point of time. So we look at a snapshot of the births over a defined period of calendar time, usually a year. Whereas a cohort analysis of fertility involves looking at fertility longitudinally. So here we're looking at births to a specific cohort of women as they move through the childbearing ages. So this could be a birth cohort, or it could be a cohort who get married at a particular point in time, who we then follow over their lifetime. So this diagram shows the difference between the 2 approaches quite nicely. If we're interested in a period measure, we might look at a cross-sectional snapshot of fertility at various ages at 2011. So we look at the levels of fertility for women at different ages in 2011. Whereas a cohort measure, we will be looking at fertility of a specific cohort of women over their lifetime. So we might look at the fertility of women who were aged 15 in 2011. So this is the cohort who were born in 1996. And we would follow that cohort as they age and measure and record the numbers of children that they have as they progress through the childbearing years. But of course, that requires them to complete their childbearing years. And for that, we're going to have to wait until 2040 to 45. So when we're looking at measures of fertility and indeed other demographic indicators, mortality and migration, we usually use rates rather than usually using actual counts of births. And that's useful because we can use rates to compare fertility behaviour across populations in space or over time in a way that we can't do often with counts of births. So to illustrate why, we can perhaps have a look at the graph on the next slide. So this shows the trends in live births since 1951. And what the graph shows is that since 1951, there are actually fewer live births than ever before. If we look at the latest data from around 2006, we can see that the numbers of live births are much lower than back in the 1960s. So this downward trend in births could indicate fewer births per woman, but there are a number of other possible explanations that we can't rule out on the basis of this graph. So we could be seeing just a decline in the overall population size, and as a result, we're seeing fewer births. Or the overall population size might be staying the same, but we could be seeing a change in the age structure of that population, so a decline in the share of the population who are women in the reproductive ages, or a combination of both of these factors. But the key thing is it might not be changes in terms of births per woman that's driving this decline in fertility. It could be something to do with population size. And rates provide one way of getting around this issue. The simplest rate that we can use is the crude birth rate. So this is just the births during a year divided by the mid-year population. And typically we multiply these rates by 1,000 to give the number of births per 1,000 population. And we can see the highs and lows of the crude birth rate in 2012, with a low in Japan of 8 per 1,000 compared to 48 per 1,000 in Niger in 2012. Again, this is a problematic measure because the crude birth rate takes no account of population structure. Our denominator is not restricted to the at-risk population, so it includes males and females, and it's not restricted to the childbearing ages. So this is a very limited measure as a basis for comparison between populations. But it's simple to understand and calculate, and it requires very little data in order to produce this measure. So the crude birth rate is problematic because it relates births to the total population. A better measure would be to restrict our rate to the population susceptible to having births. So this will be women in the childbearing ages. And this will get around the issue of differences in population structure. So the lower population pyramid here clearly has a higher proportion of women in the childbearing ages, and so we might expect more births as a result, simply because of the population structure compared to the population pyramid at the top, which has a lower proportion of women at those childbearing ages. So we need a measure that takes into account these differences in population structure. And one measure that does that is the general fertility rate. So this is looking at the births during a year divided by the mid-year population of women at the childbearing ages, usually 15 to 45 or 49. Again, multiplied by 1,000 to give us a rate per 1,000. So here our denominator captures the population at risk of an event in a way that the crude birth rate doesn't. So we have a better measure to compare across populations, since the general fertility rate will be less affected by differences in age and sex structure that might give us misleading results using the crude birth rate. But we still have a fairly crude measure here in that we know that the distribution of births to women over the 15 to 49 range varies strongly by age. So it's not the case that we have the same risk of giving birth across this age range. So it could be that the distribution of women across the childbearing ages could also affect the numbers of babies born in different places, separate to any differences in levels of fertility. If we look at the general fertility rate, we can see that decline in fertility from the late 1960s is there. So we see it in the general fertility rate as well as the number of live births. So we can have some confidence that this is a real decline in the numbers of children that women are having, and this links to a clear a driver for this, which will be the introduction of the pill in the late 1960s. What we can look at to deal with the issues of the general fertility rate is age-specific fertility rates, or sometimes referred as schedules of fertility rates. And this is where we look at fertility rates at individual years of age. And we can see here from this graph showing age of woman and the births per thousand women in Scotland in 2009, a really strong relationship. So increasing fertility up to about the age of 30, and then declining levels of fertility up to the age of 44. And we see that the shape of this curve varies between populations. So historically, we would be looking at a peak in fertility in the mid-20s, whereas today we're looking at a peak in fertility in the early 30s, common to many other developed countries. This is the formula for the age-specific fertility rates. We're just looking at the births to women at a particular age X divided by the mid-year population of women at age X, again multiplied by 1,000 as a kind of presentational choice here. If we don't multiply by 1,000, we're looking at births per woman, and if we do multiply by 1,000, our rate then refers to births per 1,000 population. So this requires more data than a crude birth rate or a general fertility rate. We need births by the age of mother, and we also need population data with age and sex detail. Often these are presented for 5-year age groups, but equally they can be calculated for single years of age. So here's a graph showing the change in age-specific fertility rates over time from 1951 up to 2009. And it's important to note that we see change in both the level of fertility as well as the shape of the fertility schedules. So from 1951 to 1964, we see an increase in fertility with the same peak in our fertility schedule around the age of 25. And then from 1964 to 1977, we see the introduction of the pill, and we see a decline in fertility. But then in 2009, we see a further decline in fertility, but we also see a change in the shape of the fertility schedule. So there's a delay in the age at which women are giving birth. So we see the peak of the fertility schedule moving from around the age of 25 to the age of 32 in 2009. One of the useful things about age-specific fertility rates is that they're the building block for one of our most commonly used measures of period fertility. Now, this is a period total fertility rate. This is a single measure that describes the average number of births a woman would have in her life if she experienced the current age-specific rates of the population. And we calculate the period's total fertility rate by summing our age-specific fertility rates. So we add up all our age-specific fertility rates. So, for example, in Scotland, the period total fertility rate in 2009 was 1.77. So this indicates that a Scottish woman in 2009 would have 1.77 children if she experienced the current age-specific fertility rates of the total population. If our age-specific fertility rates are for 5-year age groups, we need to multiply these by 5 because the rate applies for each year of that 5-year age group. And if our age-specific fertility rates are rates per 1,000, we need to divide by 1,000 in our calculation. So here's the total fertility rate for Scotland, and we can see that strong decline in the total fertility rate, giving strong evidence of a decline in fertility from the late 1960s to 2008. So this is a really useful single measure of fertility. It's one that's drawn on in the POP group software and reported in the POP group software, and can indeed be entered as an input to POP group software, but it requires a lot of data and careful interpretation. So if we're talking about a period total fertility rate, this is the number of children a woman would have if she survived through reproductive years to the age of 45 or 49, and she experienced the same age-specific rates of the calendar year in which the data was collected. So this is not a measure of the actual number of children born to a real woman. It actually refers to a synthetic or hypothetical cohort who experiences the age-specific rates of a particular calendar year. The alternative is to calculate a cohort measure of fertility. So as I said earlier, this refers to the fertility of a group or cohort of women who we track over time. This may be a birth cohort or a marriage cohort. And this is a more reliable measure than a period measure if we're interested in looking at long-term changes in fertility. So we can compare the cumulative fertility experience of different birth cohorts. And one useful measure is actually looking at completed family size of women who have got to the end of their childbearing years. The challenge of cohort fertility is we require long runs of data, and our data suffers from censoring. So we have to wait for women to complete their childbearing ages in order to derive our cohort measure of fertility. But we can indeed calculate a cohort total fertility rate, which is the average number of births a member of a given cohort would have if they reach the age of 50, or by the time they reach that age. And this is calculated by summing age-specific fertility rates for a cohort. So rather than doing this for a single calendar year, we follow a cohort through their childbearing ages and sum the age-specific fertility rates as they move through those ages. So here I have a table to show a calculation of both the period total fertility rate and the cohort total fertility rate. I have age running along the rows of the table and the year running along the columns of the table. And we can calculate a period total fertility rate very easily by just summing those age-specific fertility rates. We need to multiply by 5 because they're 5-year rates, and divide by 1,000 because they're rates per 1,000. But indeed, we get a period total fertility rate in 1940 of 1.74. So this is the average number of births to a woman if she experienced the age-specific fertility rates in 1940 that were in place in that year. For the cohort measure, we need to sum diagonally along the table. So if we were interested in the cohort total fertility rate for the cohort who were 15 to 19 in 1940, we would follow that cohort over time and sum the age-specific fertility rates as they age. So in 1940, the fertility rate for the 15 to 19 group was 15. They will reach the age of 20 to 24 in 1945, by which time their age-specific fertility rate is 103, and so on. So if we sum diagonally, we can estimate a cohort total fertility rate of 1.99. So you can see this is higher than the period total fertility rate, indicating that that cohort in 1940 experienced higher levels of fertility than was the case in the snapshot of data in 1940. But we have this problem of censoring. So if we look at the cohort who were 15 to 19 in 2000, we don't have the data to calculate their cohort total fertility rate, but we can calculate the period total fertility rate as 1.66. And this is really the key problem of the cohort total fertility rate. We need to wait until a birth cohort has reached the end of childbearing years in order to estimate their cohort total fertility rate. One solution is to fill in the missing age-specific fertility rates for a cohort using data from a cohort who have just completed their childbearing ages, just reached the end of the childbearing ages. And this is generally thought of as quite safe for gaps at the older ages where fertility is low, but it's much more problematic at other ages. So we can see here, this is the same table as before, but arranged slightly differently. Some cohorts have progressed through the ages at which they're likely to have children. But we have some cohorts who have not yet completed their childbearing ages. And so for these cohorts, we can't calculate a cohort total fertility rate. We could estimate the data, however, for some of these older ages in order to generate an estimate of the cohort total fertility rate. So which should you use? The key advantage of a cohort total fertility rate is it's less variable than a period total fertility rate. The issue with a period total fertility rate is it's subject to what are known as tempo changes. So these are changes where couples temporarily advance or delay decisions around births that affect the period total fertility rate, but not the cohort total fertility rate. The cohort total fertility rate only moves if the women of the same cohort have more or less births overall than the previous cohort. And there are a number of things that can trigger a tempo change. So changes in the law around abortion, or scares around health effects of the contraceptive pill. Some evidence in some countries of people avoiding giving births in particular years, so the year of the white horse linked to a drop in period total fertility rate in China. The cohort total fertility rate is not affected by tempo changes, only by what are known as quantum changes, where there's an impact on overall family size. But the drawback of the cohort total fertility rate is, as I've mentioned, this issue of censoring, that we cannot calculate the cohort total fertility rate for many cohorts who are currently within the childbearing ages. So that's the end of the material I'm presenting on fertility. There are a set of exercises on period and cohort fertility in Scotland, linked to council areas. You can access both the instructions, an Excel workbook, and an Excel workbook containing the answers to the exercise.